operator delete, and some other ways to allocate initialize objects in C++. Okay. I'll be talking about all the flavors of operator delete and some other ways to allocate initialize objects in C++ that use under the hood these operators. My name is Mateusz Nowak. I'm team manager located in Gdańsk, Poland. However, at this moment, I'm sitting in beautiful Lubawa, a small city here in the country. Yeah. I am slides writing machine, not only because of my role, so not only reporting things, but also doing technical presentations on different conferences like this one, or meeting C++ online next week. I do read C++ Reddit a lot, and some of the ideas for the slides comes from there. Also, I'm usual because listener mostly due to this guy. Yeah, he's the one who allows me to have some few hours saved from taking care of my daughter and giving this free time to be focused and listen to things. Just a little disclaimer for the beginning. All opinions I present are only my own and no one else's. So I'm myself and representing no one else here. Small agenda for those who like it, have visual, and first of all, looking at the slides later to the presentation. So let's start with the flavors of new and delete. There are a lot of them. Maybe first look at the screen from CPP reference from the page about operator new. As you can see here, there are 22 flavors of operator new. They are grouped and do different things. I will go through them as the presentation goes. I try to group them more or less like they're like is here, and we'll talk about them in these groups. For operator delete, there's even more variations. We have 30 of them as of C++20. And important here to mention here is that you need to be aware that one, these flavors are added with next versions of standard, and the other thing, some of the versions are changed, like first two ones that have little bit different declarations. Moving forward, let's talk about the first group, which are usual allocation and deallocation functions. Let's start with allocation functions, so operator new. Or maybe go even more back and to start with the thing that is calling is actually resulting in a call to operator new, so new statement. So how it's going in C++, we have new statement that is doing most of the time two things. First one is calling operator new, and the other is calling the constructor, the default constructor, or maybe not necessarily default constructor, depending on the call. I will talk about this later. For the object that is being created, or the array of objects. So getting back to the operator new flavors, usual allocations, there are two variations. One is throwing functions. So if you call throwing operator new, you will get exception on error. You get no throwing operator new when passing tag parameter I will show later how to pass this tag. This operator new is guaranteed to not throw an exception on error. And for both of them, we have version for single object and for the array of objects. Size parameter here is a number of bytes to be allocated by the operator new. We can also override the operator new, usual operator new for the class. So those are class-specific ones. For deallocation functions, again, we have versions for the single object and the array. And the difference here is also we have a version that does not have size parameter, and the one that is accepting size. All of them don't throw exceptions. We can override those both for the class. So we have class-specific operator delete. And also we have a variation that is called destroying the allocation. It can be also only override for a class or only defined for a class. And with that, destroying, not destroying. So again, getting back to the as you write code, to call the operator new, usually you state delete expression. And if you use delete expression that is calling non-destroying delete operator, the order of things will be first the destructor of the type will be called, or destructor on destructor of the types of the objects, or on every object in the array. And if you call destroying the allocator, the behavior is that this destroying the allocator is also responsible for calling the destructor. So call to the delete expression, that statement won't call the destructor. Okay. Moving forward, let's see an example. Here it will be a pretty simple one. We have a class with 2 members. And what we want to do here is first, as a variable v1, we allocate the instance of this class and initialize it with some value, which is resulting to the call to the operator new. Yeah, that this parameter here is unsigned long because I just copied it for assembly output. But for 64-bit architecture, unsigned long and size stays the same. And after this, the initialization with initializer is happening here. So in fact, this object is constructed with values 1 and SDKV. Next, we want to allocate memory for array of ints and put it to v2 variable. And here's the syntax that allows passing different parameters to new expressions. So we put parentheses after new keyword and between the type name. And here we put stud no throw tag. This one results in call to array version of operator new non-throwing. And if the type was not trivial, so something other than int, it would call the default constructor for all the elements of the array. Here it's int, so it's basically doing nothing. And to delete the object, single object, we call just delete statement, which is calling under the hood the destructor for the type, and then operator delete. And to delete the array, we use array version of the delete statement, which is calling respective operator delete. Here again, it's trivial type, so it don't have destructor, so destructor won't be called. Okay, moving forward. We have to mention here default and value initialization. I was a little bit talking about this when mentioning array and non-array version of operator new or of new statement. So what is default initialization? It is happening when a variable is constructed with no initializer. If T, so class type constructed is class with default constructor, this constructor is called. If T is array, every element in the array is default constructed, and otherwise nothing is done. So in best case, we save some operations on initializing in this case. Value initialization is done when initializing value is passed. So we construct with some value, initialize with some value. Let's see an example for this. We have some struct and try to construct it and allocate it with different versions. So with default initialization, with value initialization with default values, and with value initialization with some given value. Let's look at the assembly, how it will be if we have these three versions. So for default initialization, it is pretty simple. We have a call to operator new, and then value returned by it, so pointer is stored on the stack. Nothing more. When we are using value initialization with default value, again, operator new is called, then this default value being 0 for int is put in the memory pointed by what operator new returned, and then pointer is also put on stack for further use. And for value initialization, it is the same as for value initialization with default value. However, in this case, if you look at the before last line of the assembly code, we have this value of 1 put into the memory instead of default 0. And this will matter also further in some standard constructs that I will show you. Okay, moving to another group of the allocation and delegation functions. These ones are placement ones, meaning that the function is not actually allocating the memory, but using given pointer to the memory to initialize the object, to allocate the object. There are also some versions of this for single object and array. Here, as you can see, apart from size parameter, which is number of bytes, we have a pointer to memory to construct in the object in. And for this, we can also override or define user-defined placement operator. Here we have user-defined args because the standard prevents us for defining custom operator new with void pointer as a parameter. We can put any type there, any pointer to any type there, but void. And we also can override operator new, placement operator new for the class. With the allocation functions, there are also a few of them. We have non-throwing placement functions. We have non-allocating placement, which is the one that is called when object constructor throws an error. So if we have some problem with construction, this one will be called. We can define operation delete, placement operator delete on our own, and then we can have also class-specific placement of delete operator. When talking about placement, we have to mention std_loader. This is the important thing to tell the compiler that it shouldn't do any guesses about constants of the object and don't optimize accesses to this object. When it is useful, so if we have some class X and we construct it and allocate it, we can easily, without any problems, access the member of the class and get the proper value. However, then we can do placement new in place of this P object. So we are actually constructing a new X in place of the old one. And in this case, if we still use the old, so the previously used variable, which is pointing to this object, and try to access its member, we get undefined behavior, as here compiler can assume or may assume that P hasn't changed because it's const. And in this case, we don't know whether B will be the old value or new value, depending on optimizations applied. So B can be in this place either 3 or 5. To make sure this will work correctly, we have to use stdlander. And this is a simple wrapper around the pointer. However, it's telling the compiler, hey, compiler, there may be some change in the object, so you cannot assume that the value is the same as the old one, and you have to pull the data once again. Okay, also here, quick mention of stud allocators, because they're mostly defined in terms of placement new operator. So stud allocator threads, and some specialized memorial glyphs in C++20. Standard libraries rather using those, or those were developed to be used in the libraries, generic libraries, rather than the using operator new or delete directly, or using statement new or delete directly, because of the rule no make new. But I won't tell in details about them. Okay, so what we can do if those operators need it, so we can override them, and there are some rules, and there will be some examples about this. Okay, so by default, the library provides default implementation for global allocation on the allocation function, so we can always assume that those will be present, and if we try to allocate memory, it will be available there. There is a proposal I saw in last C++ standard mailing. There's a proposal to make operator new optional. So this may change in future standard versions, but for now, this is guaranteed to be there. And then on the C++ program level, we can override or redefine our own operators new and deletes in all versions, but placement new, which I was talking about earlier. Okay, so we can also define operator new and delete per class, so every class can has its own override. But here, if we do it, we have to have in mind that there are some caveats, and one of them is that list of this available overrides is changing between standard versions. So if we are doing a code upgrade, it may happen that we face some unexpected behavior because, for example, new override was defined and the code went with new path that is not coded for the class or for the program. Okay, so for new and delete expression, there is a defined lookup order. So if we override or want to use default operators new and delete, there are rules that has to be followed and some implications of the rules that are there. So for new expression, it's quite simple. If we use global scope marker, always the default implementation of operator new and delete will be called. The ones we define for class will be ignored. And otherwise, standard overriding rules apply. So first one for class, then the ones that were globally overridden by us, and then the default by ones. For delete expression, the lookup order is much more complicated. Again, if we use global scope marker, global scope, global namespace overload is selected. Then if class has defined destroying delete, so the one that does not call destructor, all non-destroying overrides are ignored. So it makes no sense to define both for the class. If alignment, I will talk about this part with alignment in a minute, in the next slides. If alignment exceeds this defined value in the standard, alignment override is preferred. Then if class has its specific overloads, if you remember, there were a possibility to have operator delete with size parameter and without it. So size unaware is preferred over size aware. So again, place where it makes no sense to implement both for a class. So you have to select either one or the other. Then if type is complete and for delete RI only, type has not trivial disruptor, size our global overload is selected. So you have to read this in two parts actually. So if type is complete, then size our global overload is selected. Or if you are using RI delete and type has not trivial destructor, again, size our global overload is selected. And in the end, it is unspecified if size aware or size unaware version will be called. So if we are overriding on global scope operator delete, we have to provide both versions because it's the matter of the compiler or library which one will be called. Okay. So getting into examples, first one will be overriding new and delete on application scope. So here in global namespace, we define this example operator new with size parameter, operator delete for a single object, and operator delete for the array, and try to create a single int and then array of ints on the heap here, and then delete them. So what will happen here? Our overridden operator new will be called twice, and then respectively operator delete and delete array will be called. So this is a situation that you have to be aware of, that if you override single object operator new, if you want to allocate an array, the default array new will be hidden, and the the operator you implemented will be used. So again, to prevent problems, you probably have to implement or override both, and then maybe for D1 you don't want to have custom behavior, just called the other one explicitly. Okay, so you can also override for the class. Here we are trying to override operator non-destroying and destroying it for the class. And what will happen here is that destroying it will be called. As I said earlier, this implementation does not make sense because always if destroying it is provided, it is preferred over other deletes. So we are just putting bloat here and unnecessary code if we have a situation like this in the code. And it's also possible source of an error. So you need to be aware of this and not necessarily put unnecessary stuff in the code. Okay, and for placement, this example is a little bit longer. So we have some type being just an array of bytes that we'll use later. As I said, we cannot override placement operator new with void pointer. It is prohibited by the standard. If we try to put it in the code, it will end up with some compile error which doesn't look obvious at the first look. So it takes some time to find what's going on. But we can override or put our custom definitions for placement operator new using different types. So, for example, we have placement new that is used when we are we are allocated in place of int or pointer to int, and we have here placement operator new that is used to allocate in place of type D. So if we in this example put array of ints on the stack and allocate new int in place of this pointer, then put on the stack variable of type T and try to allocate float in place of this T-type variable. And then if we cast T1 being array of ints to void star and try to allocate int, we will see following output. So for the first placement new allocation, so in place of int, version 1 is called. So this one that is having int pointer parameter. For the second placement new, version 2 is called. So the one that has the pointer parameter, so in place of object T. And in the third case, when we have casted int pointer to void pointer, it is resolved to call the default one placement new operator, which we cannot override. Okay. So after we gone to through the placement new and delete operators, we can see as a side topic allocation with smart pointers, because first one, there's a rule no make new. And the other thing, the smart pointers allocation is defined in terms of operator new. Okay, so what is a smart pointer? It's a pointer that is explicitly showing over ownership and lifetime. So we can state if the object has shared ownership for shared pointer, if it has unique ownership for a unique pointer, or if we are just tracking some shared pointer with weak pointer. And also it is guaranteed that if owners of the smart pointer goes out of scope, it will be destructed. Okay, so in this case, it is also crucial to remember not to make cycles with shared pointer, because then it will never delete, because it will always have owner in cycle. Okay. So how can we allocate using smart pointers? Obviously, we could call the constructor smart pointer and put their pointer to newly allocated memory, but again, no make new, and we have helper functions in the standard library to do this. We have make unique for object and array, and make short and make allocate short. Last two differs with this. So the allocate short accepts a allocator to use, and make short it always use operator new. The thing here is that make unique and make short are defined in terms of operator new, and it is explicitly stated that global override is selected. So a global version of the operator new is selected. So you cannot allocate classes that override at class level operator new with these functions, because it won't work simply. Okay, so also for C++20, we have a bunch of other overloads for those functions. Now also make short can do arrays, both runtime size and compile time size, as well as allocate short. And the interesting thing here is the functions with for override suffix, because previously those without the suffix functions were always triggering default value initialization if we didn't pass the value or parameters to the function. So if we wanted the object that is default initialized without any value, we couldn't do this. With this for override suffix, we are able to create object that is default initialized, so without any value. Okay. And the last part of the last few of the operators new and delete. Hopefully, I didn't miss any. Is the ones that are allowing to allocate with alignment. So what is alignment? We have to go back to the how memory is accessed in modern architectures. So we don't read and write memory in single bits or bytes. We read and write them in bigger chunks, usually words. Every architecture and memory type can have different size of this chunk that is read or write. So, like for 33-bit architecture, that will be 4 bytes. For 64-bit architecture, that will be 8 bytes. And if we want to have shorter read and write, so for example, want to access specific byte, it is translated under the hood, so we don't see this. For example, in PCI protocol, if we are doing DMAs, we have in DMA descriptor field that is telling which bytes from the front of the buffer or the end of the buffer to skip. So first, last byte enable. So we can read and transfer unaligned buffers to PCI device. Okay, and in current modern architectures, word size in almost never less than 4 bytes. So for 2 bits, and always is a power of 2. And going through the list of the aligned allocation functions. It's more or less gathering this aligned version from the groups I was talking about previously. The difference here is for, I think, almost every variation I mentioned earlier, we have additional parameter that is stud align validity, telling the alignment value we want to use. So we have one that can throw exception, cannot throw exception. We have placement one, and we can override them for specific class. For deallocation, again, the same situation. Basically, all we have previously, or most of all we had previously with additional parameter with alignment. And going through an example how to use it, this alignment operators you did, and it's not so straightforward as in previous groups. So here we have some class that is overriding usual new and delete, and also alignment new and delete, or alignment our new and delete. And here, if we just simply want to allocate and construct object of this class, we call usual new and delete. And as expected, we get called the usual overrides for a class. Here, this is values for these functions are simply the pointer, the size, the number of elements to be allocated, and then the pointer that is destroyed. Okay. Then we want to try to allocate with alignment. So we are passing again similar to this no throw of placement. The parameter to new expression is in parentheses after new statement and before type name. So here we have to put the stud align validity. In this case, we want 128 bytes of alignment. And what will happen in this case is the aligned version of operator new will be indeed called, but still we get usual delete. So it is not automatically deduced that we want to delete objects that was allocated with alignment using also aligned delete. How to try to resolve it? Let's maybe do another try. Let's try to call explicitly operator delete. And this slide and few next, the explicit call to the destructor to X type is missing, because if we are not using delete statement, but explicitly calling operator delete, we also need to destroy the object, unless we obviously select destroying version of delete, operator delete. So what will happen in this case? Something even more strange is happening, because now even the delete overridden delete operator, neither aligned one or usual one is called. So if we explicitly call operator delete, it will happen that as if we have global scope selector before the call, so the default implementation is called. So again, think that we didn't want it. So try again. This time we are also passing alignment value to the operator delete. And what will happen is, again, global version will be used. This time aligned version of global operator delete, but still not what we wanted. And the problem also here is that you have to put you have to remember the exact value of the alignment and put it here. It can be resolved if you are using unique pointer and passing a deleter, defining this value at the construction time, but still you have to keep the value somehow. Okay, and the last try, when we explicitly call operator delete on the instance of X, also passing the aligned value to the delete operator parameters. And now we finally get what we wanted. So both our custom operator newest, custom aligned operator new is called, and our custom aligned operator delete is called here. Again, in this case, we would have to put here explicit call to the destructor because nothing else is calling it. So we are freeing a memory in this case for the object that wasn't distracted. And about the alignment, you can also watch my whole presentation because it is a huge topic from Code Dive 2018. And with this self-advertisement, we're going to the last mention, which is PMR, which I won't cover here because it's another large story that is not fully supported in any of current implementations of compilers. Okay, so thank you for your attention. I appreciate any feedback. I will be looking at the chat and at Hopin after the talk. Other than that, you can find me on LinkedIn, on GitHub. Well, also slides from this presentation are available already, so you can go there and download it for your viewing. And I'm also available on Twitter, so if you want to contact me, you can try either LinkedIn on Twitter. And thank you once again. Oddaję głos do studia.